Hi, it's Alex from Black Sheep IT Consulting. Recently, I published a video called Base64 as a service, where you can see how to retrieve the Base64 of any attachment just by passing the row ID to a workflow or to the Siebel inbound REST API and get the Base64 string. And that's what the video is all about, and you'll find the link in the description, so check it out if you haven't seen it before, because this video that you're going to see is a continuation of the Base64 extraction. And a while ago, let me search for this, I created, 1 year ago, created this video how to use a third-party library and a Chrome extension to open attachments inline the Siebel application. So that means you just click the attachment link, and instead of downloading it or opening it in another application, you open it right in the browser. Now the old video, and the link is in the description as well, the old video uses a third-party library called Colorbox and requires a Chrome extension. So it's pretty, let's say, not ready for production. And what I'm showing you today is also not ready for production by any means. It's just a prototype, so take it with a large portion of salt. And without further ado, let me show you the output, the outcome of the physical renderer that I took from the old Colorbox, and I rewrote partially to, well, accomplish this. So we have a list of attachments in activity attachment, could be any attachments really, and I uploaded quite a big JPEG file with almost 3 megabytes, and I can click the link, and there's the file, and you see it opens pretty quickly despite being 3 megabytes in size. Okay, so that's the nice astronomy image here. I also have some smaller images from, well, the Siebel public images folder. I have Buzz here. Okay, hello Buzz. And I have, just for good measure, I've also uploaded a quite large PDF, 4 megabyte, several hundred pages, the REST API guide from Bookshelf. So let's see if we can open this from here. And yes, so that is opening in a dialog box. jQuery dialog I chose because jQuery is available, but you could use any other library to render your pop-up with this. So this is fully functional, of course. So this is not an image or a screenshot or a mock-up. This is the real PDF with 400 pages in a dialog on top of your Siebel application. Okay, so let's sit down and relax and see how we did it. So first I went back to my own GitHub repository and looked up the attachment box sample code, which is a physical renderer that the old video uses, and it's a nice starting point for me because it is the same logic, apart from the fact how the attachments are retrieved. In the old example, the attachments are retrieved using drill down, using the drill down method, and that is very Siebelish. And now we are going to take it to the next level. So I took this code and I partially rewrote it. So I called it CBox 2 for lack of imagination. And I stayed within the BindData function. So this is not really a recommended practice to just put all the code in there. There should be separate functions, but this is an educational prototype. And so what I'm doing here, first let me zoom in a little bit. Okay, so in the BindData function of the PR. We first get the PM because we need it quite a lot. And then we get the query state of the business component. So we don't want this to run if you run a query, because apparently then there's no point in retrieving attachments. We have a list of extensions, which is the currently supported extensions that we can handle. So that is kind of a limit. Other extensions we cannot really handle currently. A bunch of variables, the usual bit from the PM, get the raw record set, so we have the row ID included, get the placeholder of the applet, the full ID, get the controls, get the applet element using the full ID, and off we go to find the field names for the name field and extension field. So that is using the first record in the record set. And the reason why we do this is that each attachment business component has a file name field, but it has a prefix. So for example, activity file name or account file name or something like that. So we're just interested in the file name field name for that applet, and we store it here, and the file extension. So that would be the like test, and the extension would be PDF. Okay, so we have that out of the way. And then we get the name field control input name. So that's the Siebel code for the control that with all these numbers. So we have this input name of the field. We use it to manipulate the field later, the drill down or the name field, that is. And now we go into a loop for each record. So for each record in the record set, we first grab the extension of the record. So this is PDF or JPEG or something like that. And we have a limiter here to only run when it's within the range of supported extensions. Okay, we have X, which is the row number plus 1, so it starts with 0. So we now have 1 for the first row, 2 for the second row, and so forth. We get the row ID. Notice that we use the raw record set, so it's easy to grab the ID of the row ID of the current record. And then we use the table definition, it's a list applet after all, to find the element that is the anchor tag for the drill down. So that's the first, let me go there. So it's all about here, this drill down, this link that we are trying to manipulate. As you can see, I've changed the appearance of it, and also have to change the link. So we inject an attribute, so I can just find it later, increase the font weight to bold, and we inject attributes to store the row ID and the extension within the link HTML element, the anchor tag. So this is for later when we handle the click. So where's all the Base64? So yeah, of course, thanks for your patience. So here we are fetching the Base64 through the Siebel REST API. Notice that this requires your Siebel to be on 21.12 or higher, and requires a custom integration object. So in the previous video, check out the link in the description, you see how I create that custom integration object for the data API. So the name must start with base, followed by the exact name of the business object. So there's a custom business object that exposes the activity attachment BC. And we are going to do an asynchronous fetch for using the REST API for each record while the applet, or after the applet has loaded practically, or while it's loading. The fetches will hit the EI object manager. So if you have a standard sized applet, there will be 10 fetch requests for every user opening the applet. So this is crazy stuff. Why did I do it? Because, well, because I can, And because I can warn you here that this will cause heavy load on the EAI object manager. Imagine retrieving megabytes of Base64, and we're just retrieving them. We have to store them somewhere. And that storage I have implemented as a global variable. So we are using the browser memory, the RAM, to store it temporarily. So after the fetch is complete, every record is included in a map with its row ID. So let's go back down here, and we check if the row ID is already in there. So we're not retrieving it twice. So that of course means that when you change the attachment, you edit the attachment, upload it again, it will not be refreshed in the cache, so to speak. So this is to be done, to do that I add here for your challenge. And so now let's talk about the REST call. So this is all about the Siebel inbound REST API. So we get the base URL, which is the same as your current application. So this is like my HTTPS, my server. And then I get the business component name, because it's a generic physical renderer. I'm not trying to hard code too much here. So the business component name will be used in the URL. It's a data URL, so we need the business object and the business component. And for the business, so the business component, for example, for the attachment applet that we saw is activity attachment. And then the business component is a custom one, and I just applied a naming convention here, BCRM, my corporate prefix, space plus the business component. But you might have a different mileage here. So the fetch URL is concatenated here. Notice that we have the row ID. So we're grabbing one exact record, and we have inline attachment true. So that will get back the Base64 string in the result. So it's a fetch, so it's asynchronous. There's the first then, which retrieves the response from the response text. And that's asynchronous as well. And when that has happened, we pass in the result to the function. First, we JSON parse the result. So we have a JSON object. And we grab the row ID again. We are inside an callback function. So the variables, etc., are not accessible here. So we grab the row ID out of the result set. Nice touch from the REST API. It always includes the ID field. And then we have to be generic. So we loop until we find the file extension field and save that extension. So that's PDF or JPEG. And then we grab the Base64 from the attachment ID. So a field that has attachment ID in the name, such as activity attachment ID. And there's our Base64 string. So this could be a huge string, several megabytes. But the browser can handle it, of course, unless you run out of RAM, which is unlikely. And now we have, currently in the implementation that I've done, we can either process images, so the default type is data image. Only if it's PDF, we must set the type to data application, so the browser knows how to deal with it. And we know how to deal with it later. And here we add, this is the global variable I have. It's a map, so I set, sorry for that, I set the map element with the key, the row ID is the key, and then we append the type and extension and Base64. So that means, for example, for an image, it would be data : image space, slash, and then JPEG, semicolon, Base64, comma. So this is the prefix for a so-called data URI. Look it up. That's how you can pass data to, for example, an image element or an embedded element. And there's the Base64 string. So that's the big chunk. Okay, and now we're done retrieving the data, and we just have stored it in the cache, in the variable. So now I'm updating the anchor with a border left 4 pixels solid. So what does happen here? Let me demonstrate. Here you see that border, 4 pixels border on the left. That indicates that the REST call has been done. So if I reload this page, you will see what happens. The attachments applet gets loaded, and you see that the big picture and the PDF took the longest to retrieve. So the others were very fast. So you can, let's just do it again. Watch the links and see the border popping up on the side. Okay, I saw it. So that's pretty fast. So now it's all preloaded in the variable. So we can check out the variable, developer tools in the console. So BCRM B64. And that has 9 elements. There are 9 records. And I don't dare really expand it, or can I? It's even hard for Google Chrome to expand that. You can already see the first chunk of Base64 here. So that's the first element. So it's a huge map in memory of your browser, preloaded. So now you could already do something interesting. I'm not doing it here, but you could like show a preview of the, you could show, you know, a thumbnail image, or show the records as tiles immediately once you have this fetch done. I'm just waiting for the click, for the user to click. So I'm doing something very, very stupid. I'm pre-fetching a lot of megabytes of worth of data, and the user might not even click the link. But it's a prototype after all. Just consider the performance implications when you do stuff like that. Okay, so that's the fetch happening asynchronously for each record. So now it's all about the click. So our target is we are still record by record. And that is the turning off all the click event handlers that currently are. So disabling the default click and adding our own click event handler, stopping immediate propagation so nothing else happens, and then grab the row ID from our custom attribute, grab the extension, and grab the data URI from our cache. And the map is really very useful here because we can do a get with the row ID from the map. So this is the Base64 with that prefix that you need. And so if the extension is not PDF, so practically an image, this could require some more work, of course, then we just create an image element and set the source to the data URI and pop up a dialog. jQuery dialog, that is. It includes the image, the title is generated. Yeah, you get the idea. So let's see this for an image again. So here's the image. I click it, dialog pops up. So the Base64, let's check out that image tag. So you see the source is really, let me zoom that in for you. So you see this image source is data:image/JPEG, semicolon Base64, comma, and then it's all the Base64 we retrieved. And that of course is quite heavy, but the browser can handle it. I mean, it's 3 megabytes. Chrome handled it just fine. So that's the image that we generated inside, of course, the dialog box. Okay, just need to close that. Okay, even big Chrome is struggling a little bit, but we are getting there. So most of the attachments in real life will probably not be an image unless there are you use lots of scanned files from a scanner. Then will be likely TIFF or compressed images like JPEG or PNG. So that's already a nice way of displaying them. Of course, it's very bare bone. You can add more functionality in that dialog, make it modal, etc. And PDF was a bit of a challenge, at least for me. So, well, make this work with PDFs. I wrote here so I can get rid of that because I got it to work somehow by, well, our great savior, Stack Overflow. I found a possible solution. So for PDFs, we create a div, and within the div, we put in an iframe. Now, there could be an embed or object, but I found the iframe to work quite well. And it's just make it the same width as the dialog almost. And here's the thing, you need a blob, a binary large object. And yes, you can do this in JavaScript with the browser. So we have the Base64. So I call a function BCRM, B64 to blob, which I put down here. And in the example code, find the link in the description. You also have the link to the Stack Overflow solution that I applied here. So this is not my code, but it works very fine. It uses a trick of slicing the Base64 data, replacing stuff and slicing it and putting it back together as a blob object and returns it. Okay, that's yeah, I can't even tell you more about it. I'm pretty stoked by that code, that it works in modern browsers. And so we have the octet stream, so to speak, similar to what a browser would find when you click a download a link for a binary file. And from that, this is my blob. I converted Base64 into the blob, and now I create the object URL from it. And I put that as the source of my iframe. So the source of the iframe is practically a URL that is a binary large object, an octet stream or whatever you call it. And that container, that div with the iframe in it, is then shown as a dialog again. Okay, so that's the solution, one possible solution for PDFs. I found it that works fine for my test PDF, which is 4 MB in size. As you can see, the browser takes a little bit of time to process all that, but still it appears. Of course, you could just wait on the click, then fetch the Base64 and then convert it on the fly and do this. Or you could even, well, it's all about the Base64, right? So you could also use a different approach there, but there are a lot of solutions there. So this is one possible solution and happens to work quite fine. So let's inspect that here. So we have the div, and there's the iframe, and you can see the iframe source is, well, really a blob URL. So it starts with your server name, and then it has the well, encoding and stuff. Yeah, so that's the strange part here. But it works. So you watched until here, which is great. So we have seen how to do Base64 gymnastics in the browser, and sometimes that's a good idea, and sometimes there's an even easier solution. So let's take a look at this get URL for the Siebel inbound REST API for data. So we have our custom BO, custom integration object on it for exposing the action attachment BC, and there's the row ID. So if we just get this one record, then we will be just rewarded with plain data about the record. So there's no Base64, no image, etc. But there's a hint here at activity attachment ID is actually a URL. So what happens if we append as instructed fields equals activity attachment ID? So just requesting that one field. But if you do a get like this in 21.12 and higher, and it's a real attachment BC behind it, you get the actual binary stream back. And Postman can process images. So it just shows it. So in the header, we see that this is, for example, an image JPEG content type. So that means we can get the plain image back and display it. If a browser can display an image, then we can just place this URL, and we don't have to wrangle the Base64. The Base64 is good, of course, if you want to cache it, like in the example. You have that global variable or some other clever local caching, and you have the Base64, and it's already there when the user clicks. So that's the huge benefit. But let's say for smaller images, we can just retrieve them when the user requests it. So I've added to the code, I've added an alternative. So for the images, so we have that data URI, which is the Base64 string, but let's replace it with a real URL, with the URL we just tested. So you see business object, business component, row ID, and the fields input query parameter. So if it's not a PDF, we use that data URI as the source for the image. So the source for the image is now not a Base64 encoded data URI, it's a real URL, but it's an image source, and the browser will just download the image and get it, so just like any other image. So this code is in place already. So let me click on the image link, and you can see that it's downloading as we go. So it's not using the Base64, and let's prove that. Yes, indeed, it's to the browser, it's a perfectly normal image tag with a source that is a URL, and the URL happens to trigger the Siebel inbound REST API, EI object manager, and so forth, and returns the stream of the image. And that is a 3 megabyte image, so it's quite large, and that works fine for images. The user usually does not see any big disruption, especially for smaller images. But if you want to preload, the Base64 solution is quite handy, as you can use it to display a thumbnail or whatever we discussed. I tried to apply the same alternative to PDFs, but I stumbled a little bit, and I refrained from it because the PDF handling PDFs in the browser is quite complicated. Actually, turns out that the browser starts downloading the PDF immediately. So if you want that, of course, that's fine. But if you want to display the PDF inline, I have stayed with the Base64 solution. Okay, so, well, that's it. There you have it, a playground of sorts with the Siebel inbound REST API to retrieve Base64 or stream data from attachments and play around with these results in the browser. Thanks much for watching. Take care and bye-bye.